Okay, so we're ready to get started again. We're now going to do kind of a quick talk about Spectrum, do a little bit of a demo, and then dive into 11AC, which will probably be a little more of a discussion to see kind of where things are, how you guys are feeling about it, and we'll talk about that some more. We're going to do a bit of the demo while the discussion's going on for Spectrum, because we're running short on time, so no more slides on the Spectrum side. Most of you are probably aware of our Spectrum functionality. I think we talked about it a lot back in January. We wanted to do kind of an update of that, just show you how things are going, what's new. So we still support, backing up a step, overall on the Aruba side, we view Spectrum a little differently than some of the other people out there. We think adaptive radio management, or your network kind of by default, should be adjusting around sources of interference, choosing the optimum channel, and getting everything running. So all of our APs support ARM, and that's really where we see the core of the network health and the network functionality coming from. Then beyond that, obviously, becomes spectrum analysis, giving you the visibility into exactly what's causing that source of interference. So we support both dedicated spectrum monitors and hybrid spectrum monitors. Dedicated, we support on our pretty much entire 11N line. So 92, 93 single radio APs, 104, 105, the dual radio 2-stream, the 134, 135, 3-stream, as well as the AP 175, our outdoor AP. And coming up shortly, we'll also be adding it to the RAP3, which is one of our home access points. So we want to start getting visibility into the remote sites through spectrum analysis. So it's hardware capable. We're just working on the software now. That'll be coming out in the next couple of months. We're pretty excited about that. On the hybrid side, we're continuing to expand what we support. So we support the 105 and the 135 today. That'll be going out to the single stream AP in the near future. And what we're bringing up on the screen now is some of the spectrum analysis that we're doing.
I'm sorry, I missed, did you say the IAP was supporting it too?
The IAP is supporting it. That's actually one of the things that we're going to demo. So Spectrum has come to the instant platform. You don't get quite all the low-level charts that you get on the standard spectrum analysis, but you get a good view into what's going on, the channel utilization. And then the classifications are sent up to AirWave, just like they are from the controller. So AirWave becomes your central view into who the interferers are, where they are, the radios they're affecting, their duty cycle, their channels affected, all that sort of stuff.
And when does that ship?
That ships as part of Instant 3.1, which I believe is it's in beta now, and I'd say sooner than that. We've
end of this month.
End of this month.
Sooner remember.
Yeah. For the next couple of weeks, it's our current goal. So it'll be very soon. Anyway. Sorry, it's always a fine line to walk when dealing with the public. So that's definitely there. What we're looking at right now is still the controller portion. I just wanted to show, obviously, classifying a video bridge and some of the information that's in there. So we'll bring up the spectrum analysis screens that you have.
Maybe talk about the setup we have. So in the room, we have two APs. One is a hybrid access point that's serving clients and doing spectrum analysis. In which case, it's going to give you a visualization on the
go back
channel.
to the screen. Click out again.
And we also have a dedicated spectrum monitor that's totally covering the uni upper band on the 5 gigahertz and the 2.4 band group.
Right. So if we look here, what we're doing now is connecting essentially the laptop to one of the APs that is running Spectrum. And it's hard to read, but there's a mode column that's calling it whether it's a Spectrum monitor or an access point. And when it's an access point, we're showing you the channel. That's in that right column, whether it's on channel 6 or channel 1. If it's a Spectrum monitor, it's going to be getting the whole band. So we've connected into one of them already, the 2.4 gigahertz radio on one of our devices. Then we can just start to take a look. And here we're classifying a fixed frequency video device, I believe.
Right.
So
it's a Turk LF30S video bridge that's going to operate on the 2.4 band.
Could you turn it on? So then it's going to be turn it on. Okay.
I can't really see from here. Does that show the duty cycle? Is it at the bottom?
Right, so the top left chart is real-time FFT on signal strength. The bottom left is the FFT duty cycle. And then on the right side, you have a swept spectrogram that I believe is based on the signal strength right now. That can be adjusted. And all of these can be kind of maximized and minimized. Let me see if that helps just a little bit. I can zoom in and bring up.
So the noise source is already
right. So
been classified.
I've moused over channel 6. It's telling me I'm seeing a fixed frequency video device. I'm seeing an access point, the channels that are affected, the signal strength, and you can actually see that spike there for the video bridge. And there are a number of charts, obviously. So this is the FFT. I can change that to be the duty cycle if I want, where again, you can see it taking out and having a large impact on that channel, as well as some of the other graphs, like a quality spectrogram. So this will be the overall channel quality and health for the channels that are out there over time. This may not be the best option because it takes a little while to build up that chart, being a spectrogram. So it's hard to see exactly what's going on here, but you get the red for channel 6, blue and green over on channel 11 and channel 1. A lot of what you'd expect from spectrum analysis. There have been a lot of kind of questions about the idea of integrated versus dedicated hardware. We found integrated is working very, very well for us. It's able to work on all of our AP platforms. We're classifying the devices that we want to classify. And it's giving a lot of information through. We'll also, when we look at the instant side, we'll show you a bit of a performance demo. So we're not taking a big performance hit at all with the integrated piece. And so we'll show you what that looks like in just a second.
So is this taking over the radio?
This is in dedicated spectrum monitor mode. If I want to, I can collect into one of the others. So I'll show you what that looks like. Let me see if... So before, one of these was on channel 6 and one was on channel 1. We turned on that video bridge. It's actually already switched to channel 11. So I can't show you one of the APs seeing that interference source, but I can show you what that would look like. So if I select the spectrum monitor that I want to see, I can choose between those two radios. And AP03 is the actual access point. So here we're getting restricted to just one channel, so that's channel 11. And these are the exact same charts side by side, which isn't that useful. Let me fix that for you. Let's take a look at the device duty cycle. Right. So here I have the duty cycle on channel 11 next to some of the signal strengths that are out there for the real-time FFTs. And these are a lot of the low-level charts. We do have some higher-level charts that are a little easier to understand. You can look at things like the active devices table to see what active devices are out there. Or you can look at some of the other pieces like...
Can you export that by, say, right-click, save devices as the device list table to get the text version or Excel CSV?
Not today. All those AP informations will be available in the controller. The other devices can't quite export. You can at any point save the spectrum view to get a recording for it. Today you have to be connected to the controller to replay that. That'll be changing very shortly as well.
And then from AMP, you could probably have reports that you could do as well.
Right. So on the other side, jumping ahead in the demo, we should have...
Peter, real quick, Peter. In terms of the pervasive coverage, so our recommendation is to have like a 1.6.11 with hybrid on. If you run it that way, you're going to probably get classification from all the channels from your hybrid mode.
Exactly. The idea is you have channel coverage everywhere. You'll have spectrum coverage. And really, spectrum is most important where your APs are, because that's how are my clients being affected, what is the network health for my clients. But I'm just going to jump over to AirWave real quickly. Let me take a... I remember the name of that AP?
It's HP0.
Standard devices.
Okay, I'll just bring up all my APs. Instead of searching for the specific, you can take a look. This is AP-03. So search for AP03, find it. If I take a look, this is the high-level view, but I can drill into that particular radio. Here from the radio point of view, I'm going to see what's going on. So I can see right away, the issue detected video device fixed frequency. If I scroll down to the bottom of the screen, I can see all the detected interferers, the start channel, the end channel, signal strength, duty cycle. In this case, we're only detecting that video fixed frequency device. And if I click on it, I can see all the times historically it's been seen.
And the channel change events, also
Yep.
the reason for the channel change.
Yeah, so I jumped over a whole bunch of information because I was trying to highlight the spectrum feel. The radio detail page is really designed to give you information about all the RF statistics. So I can see things like, what is my channel utilization on this radio over time? What channel have I been on? So I can see I was on 6 and I changed to 11. And as I scroll down, I can actually see when that happened. 6 to 11 change happened at exactly 11:37. My screen's a little wider. I can see it's because I hit the noise threshold. So I started to see too much interference. My noise floor came up, and I changed channel to get away from it.
Is the history archive on that set configurable?
Yeah,
Like for how long do you keep that kind of data?
yes. So the graphs are actually going to be storing for a full year. We're looking at a short period of time. They're adjustable, just like any of the AirWave graphs. The data below, it's coming in through SNMP traps. So we're actually holding on that for a long period of time. I think by default it's 30 days, but it is configurable. So all of this is available within AirWave today. We're just kind of taking a look at some of it. You can also look at noise floor over time, clients over time, usage, channel, a whole bunch of information. There was a question back here.
Yeah, I'm really glad you're covering this. Can you help me better understand what data are you using to show utilization and to show noise? Is it data 211 frames? Are you doing a physical layer review? Can you share with us how that data is being generated?
At some of the higher levels, I get fuzzy on the exact details. It is looking at some of the actual frames that are coming through. We're looking at how busy the radio is from the radio driver level. And so receiving is when we're actually decoding those Wi-Fi frames, seeing what's going on, transmitting is when we're transmitting. And then interference is any other time that the radio is considered busy and not able to send or receive. So that can be from non-Wi-Fi or Wi-Fi sources causing that interference. Is that enough detail, or do you want to look more?
So you're essentially using layer 2 packets more than you are using the physical like layer 1 driver, or?
We're looking at the driver and getting from the driver when it's busy transmitting or receiving. So we're not looking at packet counts coming through or data flows coming through. We're actually looking for the amount of data coming through.
Okay.
We're looking at the radio driver itself for I was busy here, I was not busy here.
This is the capability built into the is it Ethos chipset now that you're using?
So that's available on all of our APs that are out there, all the 11N, all the ones we sell today, 92, 93, 105, 134, 135.
Thanks.
But for the spectrum classification piece, that's the FFTs, and we have the bucket of whatever the number of kilohertz buckets
Right.
we can use for classification.
So the channel utilization we're getting all the time, whether you're in spectrum mode or not. When you turn on spectrum mode is when we're getting the FFTs to actually be able to classify the interference sources that are out there.
And viewing those on a map?
Um,
Of impact type of thing?
I don't think we've set that up in here because we only have a couple APs. But Visual RF does have the capability to locate those on a map. It's not going to be 100% accurate. I'm not claiming that at all. We're talking 5 to 10 meters of accuracy, roughly. But we're going to tell you roughly this area of region is getting hit by a fixed frequency device. So I don't think we have it set up here. I'll take a quick look. So up here, when I choose display, I have the option to show interferers. And when I have everything defined in here, the interferers will be located. It looks like we have a few old ones showing up from other devices, a frequency hopper, cordless base, and a few others have been heard by these 4 APs and located. So there's
This is where we are.
yeah, in this room. Yeah. So I mean, really, we want to tie all this up into AirWave. And one of my favorite parts in AirWave is actually the RF history report. I'm going off of the RF health report, a little bit off script, so I apologize if the demo's not right. I just like this stuff. So we actually run across the entire network. It will look at your 10 worst APs from a few different pieces. So in this case, we don't have any problem devices. If a radio shows up in more than one list, we classify that as a problem or a potential issue for you to go investigate. But we'll look and we'll find your worst APs by noise floor. Here, everything's above minus 89, incredibly hard to see. I know you're far out. Let me see if I can actually make this a little bigger. So I apologize for the scrolling, but it's my only chance for you to have a chance of reading it. So we'll look at the APs for who has the most noise floor, who's seeing the most interfering devices, who's the most utilized by channel, and who's the least utilized by channel.
What's the time frame you're looking at?
This is a report, so it's configurable. I believe this report is run every day, but it could be over the last week, the last month. It's up to you. And the idea here is to kind of proactively find issues of APs that are consistently having problems and could be causing negative user experiences.
What do you see as accuracy of identifying sources of interference? Xbox controllers versus Bluetooth versus, yeah, exactly.
The standard.
It's pretty good. When you're in hybrid mode, it's a little bit harder for those frequency hoppers because we're only looking at one channel. When you're in full spectrum monitor mode, you're going to get slightly better classifications because we're going to see it hop around. We don't have hard numbers based on like % of devices because there's so many devices that we test. But in general, it's been good.
Do you add new signatures as customers find them or for classification?
We do, but we haven't seen a ton of requests. I think Zigbee is kind of next up on our list to take a look at.
Okay.
So we currently classify 13 or 14 different types of devices.
Mm-hmm.
In general, we found that the classification isn't as important as the impact. Right?
Sure.
So when we say, hey, this is a generic frequency hopping, that's usually enough for them to adjust around the network, figure out what's going on, and remove it. Especially because with the reports, you can start to see when did it show up, when was it not there, so you can figure out what was the delta in my environment to try and find that device.
If there's a persistent interferer, will like a microwave's obviously one of the best examples because it doesn't move and it's up, you know, channel 11 sort of end. Will APs in that area, will they keep potentially jumping back? You know, if it shifted off one once it detected it, once the AP was thrown up, or would it stay off for a certain period?
In general, we've seen microwaves, if it's just one or two, they don't have enough of an impact on the RF environment to typically drive you away from it. Modern microwaves that aren't 10 years old or aren't broken really aren't that bad.
There's still plenty of those out there, though, that are sort of causing a moderate amount,
right.
moderate duties.
So in that sense, we do have
like Australia.
a lot of these channel decisions are being made by ARM, right? So we'll be moving away from that without even using the classification.
Right.
We have some back-off times built in, and some certain number of times we have to scan to see that it's better before we'll hop back. But eventually we will hop back, and you could run into that again. It's always a trade-off of, do I want to give up the spectrum for the 10 minutes an hour the microwave is on, or do I want to use the spectrum to get more throughput?
Sure.
I was going to say, it's probably safe to say the classification accuracy is more of a software optimization function than a hardware limitation, right? So the
Yes.
more devices we want to classify, the more time we can spend characterizing them.
Yep.
So there's a dedicated spec end. Is that the same as the air monitor mode, or is that a dedicated spec end mode?
There is a dedicated spectrum monitor mode, which is different than dedicated air monitor mode. The
Okay.
differences aren't as big as you would think. So when you're in spectrum monitor mode, we will do IDS detection, we will do rogue detection. But we're scanning those channels in a different fashion. We're focusing on those channels for spectrum analysis. When you're in air monitor, we actually scan based on threats, right? So where we see activity, we spend more time than where we don't see activity, a Wi-Fi activity, that is. And because of the way the air monitors scan, it isn't really conducive with doing spectrum monitoring at the same time. For spectrum monitoring, you have to channel a certain number of times a second.
So as a strategy for deploying monitors out, would you just deploy a bunch of monitors that do the security scans and then switch them to spec end mode as you wanted to do some troubleshooting?
So before I get to that, there are a couple other reasons that air monitors are different. Our air monitors will scan the 4.9 gigahertz spectrum to look for rogues who've been configured outside of valid channels. And the air monitors are also designed for containment, for bringing down wirelessly those rogues.
Right.
Spectrum monitors do not scan 4.9 or do containment.
Right.
So it really depends on what you're looking for. Our general recommendation would be hybrid spectrum analysis on all of your APs, so you don't have the added cost of the spectrum overlay on your network. If you have an air monitor overlay, you're typically a high security customer, in which case we would recommend using air monitors for containment, and then as needed, drop it back to a spectrum monitor mode. We definitely support spectrum monitor overlays, but we haven't seen a ton of customers go that direction due to the cost.
Okay.
Is air monitor per AP or per radio?
Per radio, so is spectrum monitor, and hybrid mode,
Right. So you can have a 5 gig radio serving clients and a 2.4.
doing spectrum monitoring.
Yep.
And you can also have a 2.4 doing hybrid, and as soon as you start to see some weirdness, flip it over to spectrum monitor mode, get a feel for what's going on, and then come back. We really do recommend hybrid and spectrum monitoring. It works very well for what we see. So I do want to jump into the instant portion. So I'll let these guys hop back to the demo.
So,
Right.
greetings everyone. My name is Neil Kulkarni, and I'll be doing a quick demo of Instant. I think there was some interest of showing the new Instant having the capability of being able to do spectrum. The AP that is actually I'm connecting to is right about here. And to show the demo right now, I already have the spectrum monitoring turned on. And the AP is operating only in the 5 gigahertz right now. So that's the spectrum that I will show you guys. So if you see right now the way it shows up, there is no activity going on the AP, so the channel looks pretty clean. In the utilization it says 0%. And even the channel quality indicator shows 100% green. So it doesn't have the fancy charts, but it's very useful in terms of showing, classifying interference.
Right, so this AP is in hybrid mode right now, which is why you're only seeing that single bar chart for the channel that it's in. If it was in a dedicated spectrum monitor mode, you would see all of those. Both modes are supported on Instant.
And what I'm going to do right now with Spectrum on, I'm just going to run a quick chariot test to show if there is a performance impact with and without Spectrum.
Right, so there were a lot of questions when we first launched our spectrum analysis around hybrid mode, how much of an impact it would have on throughput. Some vendors were saying it would be 60% throughput loss due to hybrid mode. Others were saying not much, and we just want to kind of show off. We really don't see a significant hit.
I mean, the
on
numbers
hybrid
you have
mode.
typically seen in a completely clean air environment is around 230, 240. So, we're going to see what we see right now.
It'll obviously be
with,
a little lower because this
yeah.
isn't a clean environment right now.
Where's the client located?
Client is right here, sitting next to me here.
How does the, when the AP is going to change
And-
channel because it decides it's too noisy, how does it scan for which channel? Does it use ARM for that?
It is using ARM. So our APs, while they're serving clients, are always going off channel for a short period of time. So about every 10 seconds we go off channel for slightly under 100 milliseconds. I say slightly under because we want to make sure we don't miss any of our own beacons. So if we're serving clients on channel 1, we'll hop over to 6, hop over to 11, then 2, 4, 11, 6. We kind of go through focusing on channels where we've seen traffic that are active. We'll go through all the regulatory channels, not just our own, because we're finding rogue devices at this point, as well as scanning for interference levels, co-channel, adjacent channel interference, noise floor on those channels. So then
So it's actually scanning for interference on those channels when it does that hop over?
basic co-channel and adjacent channel, mostly Wi-Fi interference, not non-Wi-Fi, because it's only there for about 80 milliseconds in doing all this functionality. So then when we do change channels, we know what channels are better and where we want to end up based on it. So if one goes bad, we already know 6 is healthy, 11 is not, we're going to 6 as part of that scan. And we see no real performance hit from that scanning, because we're talking about like 1% of the airtime essentially, a little less that we're off channel.
And all the APs presumably would be sharing that information with the controller anyway, so it would have some knowledge of what that looks like from
Yep.
the other APs.
So the chariot test is...
So you can even see the channel getting utilized as soon as I start the test. And if there was any other interference, it would classify it as microwave, Bluetooth, whatever it would be.
Chariot finish.
Still running, it says. Throughput definitely dropped.
So I'm curious, how many of you, or how do you guys feel about Spectrum so far? Is it a game changer, a nice to have?
I don't really like Spectrum. I've never used one already.
Yeah, definitely more the better.
For me, I don't think,
I know you're gonna.
for me, Spectrum's important, but for me, the biggest interferer is co-channel interference. So when I look at, and I probably learned that from Keith, but when I look at non-Wi-Fi interferers, I see a lot of Bluetooth and I see a lot of low duty cycle, and unless there's a lot of Bluetooth in a small area, I just don't care. So I only address them when they're the continuous transmitters or fairly high duty cycle. So
And I have seen quite a few environments with high duty cycle interference that just act very strangely, and I couldn't find them even with a directional antenna.
Yeah.
for me, it's because it's part of the Atheros chipset now. I think most vendors are doing it. So to me, I kind of expect that it should be there, but it's not a massive game changer for me.
So it's not a go-to debugging tool or anything?
Well, I know I do look at it, but
It's more like another data point of information. That
yeah,
Right.
it's not a,
Okay.
yeah.
Use it acutely, use it as needed.
It's good to
It's
have
another
some-
tool that you have in the bag.
This afternoon. The only thing you can do when you find an interferer is change channels. I still have to get off my butt, go out and do it and fix the problem. So I still need to have a mobile spectrum
Yeah.
analyzer that I use and know how to use.
So there is one feature within the control, you mentioned the Bluetooth, that I would recommend. It's called non-802.11 interference immunity. And it's configured at the AP group level, and raising that up will do some work to get around Bluetooth. We had some customers that were an all Apple shop, and so they had Bluetooth keyboards, Bluetooth mice, Bluetooth phones, it was high density, and they were starting to see significant interference from Bluetooth. By increasing that interference immunity level, they were able to significantly increase the throughput of their network from 5 megabits to around 100. It's not going to be perfect. When you do raise the non-Wi-Fi interference immunity level, you give up some of the max potential throughput and some of the coverage area, because we have to shrink some of that down to get around the interference. But it is an optional controller.
A lot of folks around here on this table is more integrators. I'm an end user, and I can tell you, managing 7, 8 hospitals, this is a valuable tool because I'm not there, so I can flip an access point onto Spectrum and just use that as yet another tool, right? There is value in the mobile, but there's also valuable information. Is this something you use every day? No. But when Nurse Betty calls and complains, hey, I'm getting kicked off, well, it's really quick for me just to flip an AP on to see what's going on.
Yeah.
But then you might, everybody else.
Well, if you design your network right, you should have one for every 4 or 5 APs that you should be able to turn on.
Yes, agreed. And that's a lot of my customers, if they have issues, it's the first thing I tell them to go.
It's just another tool, but it's a tool that's definitely needed. I wouldn't say stop what you're doing because every manufacturer has their own version of it, right? And you don't want to fall behind in times, but it's certainly a tool that does get used, but it's used when you need it, right? And you need to have all that information when you need it, right? So it's a valuable tool.
Cool. So is the chariot test finished?
Yeah. I think this one, yep. I'm just gonna, this is with Spectrum, no, I'm just gonna run it for a lesser time.
Well, so we just got rid of all the results?
Yeah. Should be quick.
Okay.
Okay. So these are the.
That's the live result.
That's the live result.
Okay.
That's with Spectrum enabled and hopefully.
So can you hop back to that so we can see it for a second? So how many clients do we have here?
Just one client right now. Max TCP performance test is what's it's showing.
Okay. And how much is getting pushed through?
It's showing around 230 to 27 megs.
So 227 megabits, 230. It's roughly where it's the line. Just hopped up a bit. So
230 megs. Single client peak TCP performance with Spectrum.
right, so the final average was 234. Sure.
Yep.
Okay, and then we're going to turn hybrid Spectrum off.
Yep. So
here we're going to instant. We're going to go into the configuration screen. Spectrum is under one of the advanced radio options, and there it's enabled. So now we've applied and disabled it on both radios. You can hit OK. And while that's running, can you hop back to the instant URL?
So now if I actually go back here, my Spectrum link will go away.
You may need to navigate to the screen. Back.
Load.
How many of you have played around with Instant yet?
Yep.
Absolutely.
Great. I think we have a giveaway later, is that right? In the future, we'll be
So
shipping you guys all.
It went down.
It,
I think it's just a variable, but
Yeah.
point being, we don't take an impact with Spectrum enabled.
So hold it here for 1 second.
So turn on, you go faster.
Right, so now that it finished, it did about 218 megabits per second instead of 234. Obviously, a 30-second test is a little variable, but it does kind of prove the point that we're really not taking a performance hit. You're not going to see a significant loss by running in hybrid, and that's one of the reasons we do recommend hybrid being on all the time.
There it goes. 235.
So I think you get a pretty good idea from the performance side. That was definitely a lot of the questions seemed to focus around that before, so we wanted to make sure we showed some of those results.